Welcome back to another explainer. Look, today we're diving into something really fascinating, the Immediate Access Store, or IAS. But we're not just going to sit here and read the textbook definition to you. No way. We're actually exploring direct behind-the-scenes insights from Cambridge examiners to see exactly how they approach the 9618 computer science syllabus. It's basically a cheat code to figure out what the graders are actually hunting for when they look at your paper.
So, here's our quick roadmap for today. We'll start by laying down the IAS foundations, outline a procedural framework, and then get into critical analysis. After that, we'll cover a massive method mark strategy, and finally, wrap up with some direct examiner warnings. Let's get to it.
All right, Section 1, IAS Foundations. Okay, so examiners actually design questions in this area to test entirely distinct cognitive domains. The immediate access store isn't just a, physical component on a motherboard. In the exam context, it is treated as a theoretical architecture. What does that mean for you? It means your answers have to rely on super precise definitions and, crucially, causal relationships. Like, if A happens in the IS, you've got to explicitly show how that causes B to happen in the processor. It's all about proving your systematic, evidence-based reasoning. And this brings us to our first major examiner insight. The principal examiner reports point out a really clear trend. Candidates who make cross-topic connections achieve significantly higher marks. It's huge. If you treat the AIS like its own little isolated island of information, you're literally capping your score. But if you integrate it with networking, processor architecture, or data representation, that holistic understanding is exactly what they want to reward. Moving on to Section 2, the procedural framework.
Knowing the theory is great and all, but actually sitting there in the exam hall, that requires a really systematic method. You should mentally walk through this 5-step sequence every single time you see an IAS question. First, identify the key elements. Second, apply the relevant principles. Third, execute your analysis with crystal clear working. Fourth, verify if your results actually make logical sense. And finally, present them using the correct terminology. This flow isn't random. It perfectly matches how examiners build their marking schemes.
Because the ISS often requires algorithmic thinking, you really have to use strong action verbs in your answers, perform step-by-step decomposition, show your appropriate data structure selection, demonstrate efficient code implementation, and wrap it up with rigorous testing. By doing this, you're actively proving you meet those assessment objectives instead of just passively reciting memorized facts.
All right, Section 3, critical analysis.
So this is where we shift gears to those higher-order assessment objectives. This is literally where the A and A-star grade boundaries are fought and won. To conquer these complex questions, you need the deconstruct, solve, evaluate loop. First, deconstruct the prompt to find the logical steps. Next, solve it systematically. And finally, and pay attention here because this is what so many students just totally skip, evaluate. Check your answer for reasonableness and make justified recommendations. You absolutely have to provide that conclusion to get full credit. When doing comparative analysis, examiners constantly note that students just list a bunch of facts. But true analysis, that means identifying similarities and differences. You've got to use comparative connectives, words like whereas, conversely, or similarly. And you have to support every single point with evidence to draw a conclusion about relative importance. You're not just defining things in a vacuum, you're putting them head-to-head in the ring. Which leads us perfectly into Section 4, the method mark strategy. Honestly, if you only remember one tactical piece of advice from this whole explainer, let it be this exact quote from the principal examiner report. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. It's kind of crazy when you think about it. Examiners are basically looking for excuses to give you points. If you make some tiny arithmetic mistake, but your systematic processing is totally flawless, you're still going to scoop up the majority of the marks. So let them reward you. We see this play out most clearly with complex binary representations. Look, interpreting these is notoriously difficult. And let's be real, it is incredibly easy to accidentally flip a bit when you're under the pressure of a ticking clock. That is exactly why showing your analytical framework is so vital. If your final translation is a little off, but your written steps prove you knew exactly how the IAS processes that data, you still get the points. Always show your work.
And finally, Section 5, examiner warnings.
We dug deep into the examiner reports to find the absolute most common ways students throw away marks. Number 1, vague answers. Examiners absolutely despise a lack of specific technical details, so you've got to be precise. Number 2, forgetting to check boundary conditions and edge cases.
You have to prove you thought about the extremes, not just the standard, run-of-the-mill inputs. And number 3, answers not specific to the question's context. A generic, memorized textbook definition just isn't going to cut it for a highly specific embedded system scenario. You must tailor your knowledge to their exact question.
So, we've covered the theoretical architecture, the systematic processing, and the critical traps you absolutely need to avoid. I want to leave you with a challenge. How will you apply that deconstruct, solve, evaluate method to secure every single method mark on your next past paper? The next time you sit down for a study session, treat it exactly like the real exam. Show you're working, use those comparative connectives, and make sure your context matches the prompt perfectly. Thanks so much for hanging out with me for this explainer, and I'll catch you in the next one.